3D printing. Next. You have to swipe. Smart goal. Our challenge is to come up with your own invention or product idea. Design a draft prototype using Tinkercad, then evaluate your prototype. See if you can find ways to improve it based on what you discovered through analyzing the design. That's what our challenge was. And our smart goal is it.
Alright, about your technology. Tinkercad is an application that is a 3D model maker. It also links printer brands. So you can print it off Tinkercad and not have to do any different thing. Most people use it to make models from scratch and save it to build in grid. The computer brings the 3D object to the grid, so it is ready to print anytime. I think it is a good thing to use for beginners because it has some built-in shapes to kickstart your creativity. Tinkercad is a good starter modeling app, but it might be too unadvanced for expert modelers. Tinker
That's the app. People use 3D models every day in life, pretty much in every way. Most people use it for holders and extra space for a crack or a hole in something to patch it up. You can also convert 2D models into 3D models using this app. People specifically print things to help them in real life too. For example, people 3D print handles and holders for items. You can also make tools or covers depending on the size. People use 3D modeling every day to make some life easier. So that's the take your CAD wrench and then they print it. Yes, it is.
What problems did you have? The problem we had was how to fix the model if the 3D printer makes a slight mistake. If there are any errors, it could mess up the whole process. So if there was
And a skew.
whatever you just said, piece of filament for the support, it could break or tip the whole model. Or a slight.
So I can say something.
Boy, what?
Cut.
Or a slight mistake can mess up the whole circumference of the model because of a tiny piece of filament. We mostly finished some models. We had no other problems. This is the
On a completed model.
yep.
We learned how to operate Tinkercad. Basically learned the basic parts to be able to print a model. We learned how to scale and change support types and thickness of the model. We learned how to make a pyramid and a prism onto a grid. We had to calculate the area and the volume of the 3D model so it fits perfectly onto the grid. If it was balanced around, it could topple over and ruin the whole model. We have to add supports also. So just tip over.
Completely done 3D model. Day one. Guys like assignments? Yeah, you like it. On day one, Cam and I worked on some separate models. I worked on by Eric Wasvik. Cam messed around with Tinkercad and learned how to operate it. Yeah.
Day two, Zed started printing 3D model. Cam was in the process of making 3D model. Problems Zed had was the print messed up, so he had to do pictures.
On day three, I started the print on the other printer. Cam's print broke or something like that on the one printer, so we had to move it to the good printer. The only problems that we had was prints breaking a bunch.
Day four is then I finished all of our prints. I made a bunch of keychains. Wasvik. Cam made one thing, it was an elephant, and it had a bunch of stuff on it like a sword, but it fell off. That's the second one.
On day 5, this was the last day, we both just messed around on Tinkercad. We both made some models and stuff we could print them. This is like the big punch stuff right here.
In conclusion, I think that Tinkercad is a fun, challenging project that someone enjoyed. We achieved the SMART goal by finishing the model and completely printing it out. I would do this to launch it again if I was able to work on the model for a few more days, then I would be able to finish it. Yeah.
You're supposed to delete that.
We had many successes in the models, only one of them great. We spent at least $12 worth of filming to make all the models. Me and my partner had no need to work together because we both had different models. The vocab.
Sensation.
That was dude. What?
Whoa, you're crazy.
16 crazy?
So how like?
Why didn't you just do
One, just do
100?
101.
There's no numbers. 100.
I get 102.
100.
What's Anne's choice, Lucas? 100.
Wait, what's ours on it?
Yeah, man, you suck.
What's it? It's ours?
Yep.
Yep.
Sorry. Oh, crazy.
You get that side.
Okay, so how long was I?
Good card.
At the end, are you able to move the camera to show the
Okay.
thing?
Alright, bet.
It was pretty different. And just pull
Yeah.
it up on the whiteboard.
You get digital.
Wait till one on the left. Perfect. Good.
Alright, we got DAR hunting game. Yeah.
Alright, our SMART goal. Our challenge is to design and program your own interactive computer game as you learn advanced programming techniques in Scratch. It's our SMART goal right there. Specific, we will use Scratch to create a hunting game with coding, measurable. In the next 4 days, we will be able to create a fun and enjoyable hunting game. Attainable, we are using Scratch and tutorials to help with coding the game. Relevant, you both have used Scratch in the past, and we think it's fun to make a game. Time-based, making sprites and backdrops on workday 1. Start coding on workday 2. Continue coding on workdays 3 and 4. So game in action.
Yeah.
Awesome.
About your technology. Scratch is a program used for coding by lots of people around the world. It uses simple code for people to learn how to make their own games. Scratch is a very beginner-friendly, and it also allows people to connect on the website. You can view other people's projects, leave comments, and friend them. And then that's some other person's coding on Scratch.
Relate your launcher to the real world. Scratch is used every day to make or play games. It's a relatively simple coding program compared to some of the higher-end ones used to make large-scale games. Our game was inspired by The Hunter Call of the Wild. This is a high-quality hunting game played by thousands of people every day. Ours is a lot worse in comparison, with a large-scale game took years to make with a big group of people. With enough time, we can make a good hunting game on Scratch. It's our hunting game. It's called Wild. Not saying I can compete with them, of course. I know.
What problems did you have? In the beginning of the project, we had trouble figuring out how to properly save the game. That problem caused us to restart multiple times and lose valuable time that could have been used to improve the game. To solve the problem, we had to ask Mr. Ponzer how to save it correctly. And after we found out how to save it, we didn't have any more problems with saving the game. And then that's our save file right there.
What did you learn? We learned how to work together to code a video game. In Scratch, we learned about different sprites, costumes, backdrops, and sounds.
Alright, sprites. One of the more time-consuming parts of our project was making the sprites. We spent almost 2 days making the sprites for our project. The deer sprite has multiple variations, including standing right, standing left, walking left, dead right, and dead left. There's also sprite variations for the antlers. So we have a spike, and then we got big rat. This is standing left, and then this is a big rat.
Sprites continue. With the sprites being the majority of the project, we spent a lot of time on them, and it took a decent amount of time to make all of them. In total, there are 6 sprites, but with those 6 sprites, there are 21 costumes. Each costume is slightly different to make the animations even better. It's the weapon sprite right there. That's the menu screen.
Yeah.
Some awesome sauce.
Coding. Each sprite had its own separate code. Coding allowed the costumes within the sprites to switch, which gave them a kind of animation. There are different kinds of code such as movement, audio, variables, and mold. That's like one of the biggest parts of our coding. Coding for the deer.
Yeah,
And
man.
the walk and stuff.
Sounds. A game without sounds would be boring. So we had to make our own sounds using a microphone on a computer. The shooting sound effect was made with a chair that we dropped on the ground. Some of the sound effects we got were from the preset sounds in Scratch, like the bird sounds and the menu music. We got the reload sound effects from a YouTube video. That's the music loop right there.
Yeah, that's a menu screen.
Crazy.
Dude, at the start of the project, we had to plan out what the days we're gonna what days we were gonna make the audios, which days we were gonna code, and which days we were going.
Spit it out now.
What's easier? I said the same thing twice. All right, on day 1, we made the sprites, and then the rest of the days we made the audios and coded. It's more code.
Yeah. Conclusion. It's our challenge again. We're not going to read that. Sum up your launcher. We met our SMART goal, although we didn't get as much done as we hoped. We achieved our goal. We would do this launcher again and use what we learned from using Scratch this time. We liked the simplicity of Scratch and seeing the final product. We made a hunting game with different antler variations. We learned how to work together as a group and how to code. We worked together to code, draw costumes, and make sounds.
That's just vocab with no rewrites. All right, let's go. No clapping yet. No clapping yet.
Wait, you didn't even
Wait,
you didn't highlight your vocab. Wait, you didn't highlight your Yeah, show off our hunting game.
Oh, right here? Here's a good house on it. All right. Music right there.
Show off the
Here's the controls.
Wow.
There's a deer. That's the smaller antler variation. That's the shoot. Dirt nap.
Yeah.
Yeah. See if we get a bigger antler variation spawn.
It didn't
It's
spawn.
the same one, so we restart.
No more. It's the same one. There we go.
There we go. Wait for him to walk out. Boom. Crazy. This game's insane. Absolute cinema. Thank you. Thank you. Thank you. Thank you.
Wait. Get the vape. Wait, you didn't highlight your vocab.
Our vocab was on. Or we don't have to highlight that.
I'm blind. I know. I was.
Let's go, guys.
Oh, 1009.
I want 1,000.
Why did you just put 1 and 2?
I want 1,009.
Okay, we'll take 10.
We'll take 10, 10. Ben 10.
Dang!
We're really good at fighting.
This is gonna be a rough one.
It's gonna be a rough ride, guys. It's gonna be a rough one. Alright. Arrow Bird's presentation by Arrow Bird. SMART goal. Specific. I'm going to create a replica of a game item or character that was gadget from R6. Yeah. Measurable. I will make a 4x4 inch 3D creation. Attainable. In 7 days, I will attempt a 3D creation. No! Relevant. I will use Tinkercad to create a replica of Gadget from Rainbow Six in 3D. Stop it. On day 1, I will explore, and on days 3 through 6, I will work on the masterpiece. Number 2 is the SMART goal. About our technology. My technology is 3D printing. How 3D printing works is a machine melts filament, which is basically plastic, and it melts it, and because it is melted, it will stick together and cool down so that it forms a wall-like form. Because of that, they can use it to make large-scale objects such as rockets or even bricks. 3D printing is also used in large-scale companies, well, large-scale production, such as chairs and seats. However, it is mainly only used by one company because it's not accessible. It's very expensive. That's a 3D printer, believe it or not. Relate your technology to the real world. Our launcher relates to the real world in multiple ways. You can use it to create small objects to patch holes or fix wobbly desks. However, there are a select few companies that use it for production. As you see in the picture, someone made a rocket with it. There's also a company that makes like spinning chairs. This will prove it has multiple uses. What problems did you have? I don't know if the label from the picture went. There were many problems that I faced while working. Some of the bigger problems were stuff like trouble rotating objects or not enough objects to work with. However, some of the small things were like Tinkercad automatically being in the Imperial system. There was many ways to fix that though. The bigger problems weren't that hard, they just needed practice, and the smaller ones I just had to click a few buttons to change it to whatever. I already forgot. What did you learn? On this launcher I learned a lot of stuff, but I will go over it day by day to help, like, spread it out. Work day 1. On work day 1, I started on a private day. Throughout this day, I was thinking about what I wanted to do, but today I cycled through about 4 designs that end up with the track from Rainbow Six that covers, is being covered up by the picture. Can't see the words. It's not flipping. Day 2. Today I learned that Tinkercad doesn't fare well with movements. There's problems with snapping and not going where it should. On day 2 though, I had continued working through this problem. That's what I did today. Day 3. Today was probably the most important day. I learned today that nothing can print without support, so that means that this was the basis for my final print. My failed prints, as you see, it's just a lot of bases that didn't finish. Day 4. Today I learned that printing takes a lot of time. My print took almost 4 hours to complete. Along with that, I'm not able to really choose what color I want my print to be. Just depends on the printer. Final day, / reflection day. On this day, I looked back at what I had done. Today we were not really allowed to work, which had to work on the conclusion. That's Tinkercad. Conclusion. It tells us what our challenge up there. And our challenge is to use Tinkercad to design a 3D shape based on a real-life object or structure. I don't think that I achieved my SMART goal. I did manage my time well, but I kept on switching in between what I wanted to print. Overall, this launcher was easy too, so I think I would do it again. I really like that there was a lot of freedom because it just helped me be able to cycle through prints. I had successes because I was able to swap what I wanted to do and still get done. I didn't learn anything though because of how easy it was, and there also wasn't a lot of detail, so it was pretty easy. Well, it was pretty uneventful. Yeah, there's all the vocab.
No.
And I don't have my print because somebody stole it.
You were in French the whole time.
Sweet.
Why are you doing random numbers? There's only one group.
Why are we doing
this?
this? Alright,
Lucas, pick a number.
I picked the first one.
3, 3, 3, 3.
3.
Dang
it!
Move your leg.
I was trying.
Got it.
So was that no impersonation?
My friend.
No, you are not in front.
My friend now.
Yes.
Yes.
You are also covering up all the words though. You're still covering up the words.
Can I close the blinds?
You're barely in frame.
Yeah. Alright. Well, we'll start here. Mars rover. Meet Lucas. You can't skip it. That's cool.
SMART goal. Your challenge is to build, code, and collect data from a robotic rover kit using UKit Explorer, formerly called UKit Advanced. Then calculate the speed of your robotic rover as it travels across different terrain surfaces, and determine the relationship between the type of terrain and the speed of the rover. Our SMART goal. We will use UKit Advanced to create a rover that can track speed on different surfaces by using the equation to find speed. In these next 4 days, we will be able to build our rover and test it on different surfaces. We'll also be able to follow these steps online. What prior knowledge do we have to help reach our goal? We know the speed equation and how to build the rover. We're creating this because we like building and coding different things.
About our technology. The UKit Advanced technology is used to teach about building and coding. When building with UKit Advanced, it gives you a step-by-step process on how to construct the model. After finishing the build, it also has directions on how to code it. While testing the speed, it has different variables. There are independent variables and dependent variables. UKit Advanced is a fun way to learn how to build and code. Our different wheel options, we stuck with tires.
Relate your option to the rover. UKit Advanced Rolling Rover relates to the real-world Mars rover. Robotic engineers design, test, and repair and deploy robots. They design robots that solve problems and program them to complete difficult tasks that humans may or may not be able to easily do. For example, the Mars rover must be able to collect samples from the surface of Mars, traverse difficult terrain, etc. Robotic engineers had to design a rover that would be able to travel across surfaces that are rocky and have many obstacles such as craters. Our rover can't sense other objects in front of it like the real Mars rover can.
What problems do we have? On the first day, we had a problem getting the motherboard to fit into the right spot on the rover. We overcame this challenge by looking back at the steps and finding the exact spot. Another problem we had was our code didn't save. We ended up having to redo all of it. The tracks we used weren't working because the servos were collapsing. We decided it would be better to use the wheels instead of the tracks. The last problem we had was all the wheels wouldn't turn at the same time when we would turn left or right. This caused it to go backward or forward when we hit the left or right arrow. We fixed it by looking through the code and finding what was wrong.
We got half tracks, half wheels. Well, what did you learn? We learned that the UKit technology is very tedious. The Bluetooth chip only worked for about 10 minutes on the first day and never worked right the rest of the project. We also learned that the coding was quite easy. We realized that the tracks we tried to use were never going to work because of the way they should. We learned that the pieces were very loose after being built and torn apart multiple times. The parts were very hard to get apart or together. The tracks, you can see they're too tight, bending that right there.
Build day 1. Today we completed steps 1 through 101 of our build. Building today, we realized we might be missing some pieces out of our kit. This might be due to dropping our kit during the project. It also could have been previous groups using. We got a very good amount of building through by stealing pieces from other kits and finding some of our missing pieces. We were over 1/3 completed in just 1 day. That is our
that's
steps 101.
Just in 1 day, that's what we got. Build day 2. On day 2 of building our project, we learned there's a steep learning curve to our coding software. We finished building the robot on this day and began coding it. It took us a while to learn our coding software and complete some coding. We can code the 4 wheel motors to spin all at different speeds. It took some different equations and expressions to make all the wheels cooperate and collaborate together. We also didn't have experience coding something as complex as the 4 wheel motors. Opposite, this is the front. This is where the wheels are supposed to go. It's got eyes. Yeah, picture of the eyes and the 2 front wheel motors of the rover.
Build day 3. Today experimented with the interchangeable wheels and tracks. We initially tried to put the tracks on the rover, but the tension on the tracks was too tight and was pulling other pieces of the rover apart. We overcame this by both putting more links in the tracks. We also just decided to leave the wheels on so we had no issues of the track hitting the rover. We coded more of the software for the robot to function. We have multiple different lines that all do specific things with the wheel motors and speed of the rover.
Build day 4. Today we had a good enough code to drive the rover down the hallway. I accidentally stepped on it and the wheels went off, basically exploding. This code was as far as we were going to get since it was day 4. We would have liked to go further, but the software was not cooperating on the first day.
looks like a fair amount of commands coded and ready to use. We did very well on time for not needing our smart goal entirely. We got 5 lines code.
This is a video of our rover. We were unable to transfer the video from iPad to Chromebook. The camera on my computer also, or Jack's computer, also isn't functional. So there's a picture of our completed rover before we start.
We just test the code right now.
Right.
Conclusion. Challenge. Yeah, I already read that. Conclusion, we did not meet our smart goal. We met it in some aspects, but did not in others. We accomplished building the rover and coding it to do some commands. We, however, did not accomplish all the code we wanted to get done. We wanted the rover to get the code to go over different terrain, but ran into difficulties trying to figure out how to get the code to behave on flat terrain. The coding software was not saving properly from day to day. Overall, almost meet our smart goal. Okay.
Stop fiddling with the camera.
I'm making it work.
Alright.
Alright. Invite on the wrong way.
Go forward. Then backward. Maybe.
Oh yeah.
As one of the wheels doesn't spin.
It doesn't turn very well.
Good move,
It's turning the wrong way. But that's okay. It doesn't turn right. But you make it stop. Boom. Easy.
Done.